Yeah, I'm very happy to be here. I'm going to talk about the work that I and my students have been doing for about 10 years now. I was writing a review article and I realized this could be a nice talk. So I call this Anytime, Anywhere, All at Once. And if you haven't seen the movie, which I'm obviously inspired by, there are no spoilers here, although you should see the movie. That's a good one. And my subtitle here, Data Analytics in the Metaverse, of course, a little provocative. This word means nothing nowadays, or this is an effort to reclaim the term, and I'll try to explain how in the next few slides. But the basic premise of the work that I do, at least this slice I'll talk about today, is the observation that in our today's society, we're increasingly collecting data everywhere about what's going on, not just online, but also in the real world. You know, all the purchases, our movements, reviews, decisions we make, products we buy, so on, is being tracked. And if we take all the privacy and security problems with this, and there are many, and put them aside, we can think of the possibilities of using this data for decision making and personal uses, as well as for professional uses, maybe for companies and similar. So increasingly, we're also seeing that this data is being used and analyzed anywhere. Because of course, we're all accustomed to having smartphones in our pockets, and we have all kinds of apps and services available to us. The question is, what would data analysis look like when it can be accessed anywhere? So the overall idea of this everywhere and anywhere data, that's the starting point for my NSF career in 2013. It's been almost 10 years. But it's this observation that we have data from everywhere. We can access it anywhere. We can think of data now as a utility. The question is, what kind of opportunities would be available if we can start putting this data to good use? Now, a little bit about myself. You heard the intro. I am originally Swedish and came to the US in 2008. I was a professor at Purdue, came to Maryland in 2014, and I became the director of the HCIL in 2016. And I was a director for 5 years until it was a good way to step down last year. So I was the 7th director. The first was Ben Schneiderman, who founded the lab in 1983. And since 2019, I'm a full professor. And the work I do in general is data visualization. Maybe I have short attention span, or maybe a better word for it is I'm a generalist. So I've worked across the entire spectrum of data visualization work. The kind of applications, of course, that I'm concerning myself with today are, first of all, these mobile field settings. If you are on your own, solo, on the go, and you have your mobile phone available, what kind of data analysis would you be able to do? At the moment, these kinds of device applications are not very common. The data visualization field hasn't really looked so much at them. When you move into a group setting in the field, you might have more than one device available, multiple people. But in this case, you'll see these two young women. The devices are not really helping them. They're trying to look at each other's screens. Here's the challenge. How do we make these kinds of situations more practical? Maybe you find a place to put down your computer. You're in a more static setting. You're no longer on the go, coffee shop or your office, maybe a conference room. But here the challenge is you probably have more than one device at your disposal, but current devices are designed for solo use, not really for multiple devices at the same time. So the fact that you have a smartphone and a laptop and a tablet is not going to help you. So how do we look at situations where we can have these devices stack and multiply? And this becomes even more challenging in group settings, conference room. People show up with their laptops, just sharing information or making effective use of all this display space is challenging. So even if we have multiple devices, they don't really multiply, they don't really stack, at least not for data analysis sessions. So put these 4 settings together, you get the playing field for what I call ubiquitous analytics, which is essentially a blending of ubiquitous computing and multiple devices from that realm, and data visualization and visual analytics. Now, of course, if these discussions sound familiar, it's because they are. This is Mark Weiser. He's the head of the computer science department at Xerox PARC, just about 3 miles from here. I looked up before I came here, which is really cool. And in 1991, he wrote a famous paper called "A Computer for the 21st Century." And the quote you see here is the very first line of that paper. The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. And of course, you can make a case that today's environment with mobile phones, smartphones in every person's pocket, more than, I think, 6 or 8 billion of these devices in existence today, most of them now able to access the internet, means that ubiquitous computing is here. It has come. We don't just recognize it. It looks slightly different from the vision that Mark Weiser, who's hailed as one of the fathers of ubiquitous computing, thought of. You know, he talked about disposable tabs, computers, tablets you could use and then throw aside so they were not personal. They talked about making devices in your surrounding area speak to you or provide information. So we have a similar situation. It just looks a little different. And this argument was discussed a couple of years ago in an article on saying, Chris Harrison and others saying that what we have today is more of a quality computing situation. We have one device, one personal device, maybe a tablet too, instead of lots of disposable devices. But we still have this situation. And the question is, what does this look like when we apply data visualization to work? So that's the starting point for the work that I began around 2010, and then we had an NSF career in 2013. So I call this ubiquitous analytics, and I thought of this as the use of multiple networked digital devices to enable a metaverse for data analytics. And this word here, again, it's a convenient shorthand for thinking of these a data world, a parallel world to our own that we can pierce, use multiple devices as portholes or even immersive devices to see, so that we can analyze data anytime and anywhere. Now, what would you want to do this? Of course, the technology is there, but I also want to point out that there are good reasons from human cognition that says that distributing our sense-making of data into our environment is a good idea. So so-called post-cognitive frameworks that have been around for about 20, 30 years in cognitive psychology. So these are things like distributed, socially distributed cognition, extended cognition and embodied cognition. They say that cognition, human cognition, is a system. It's not just what's inside our skulls, in our brains, but it also involves other people, physical artifacts, history, etiquette, culture. All of these things contribute to helping us think. So to bring this point home, just imagine things like Post-it notes or your calendar on your phone. These are extensions of your memory. We have physical environment and the way we organize our physical space to help computation. So just imagine cooking food and arranging all the ingredients that you still haven't put into your dish on the left side of the dish, and then the ones that you have on the right side. So we commonly use physical space to aid cognition. And also just the fact that if you have a group of multiple people, they provide multiple viewpoints, they provide multiple expertise and different roles in your collaboration. So that's another way to think of cognition. You know, even if people in a group, they're not neurons, they're not synapses in the brain, they are still components of a cognitive system formed by the people that contribute and collaborate. So the whole premise of my work here is to say, if we're going to distribute computing, we can better scaffold and support sense-making by making the devices that we already use active and part of the sense-making process. And of course, as I mentioned already, as technology progresses, we start to see augmented and mixed reality devices and displays that enable us to put computer graphics or content on the world itself to further support this kind of setting. All right, so I'm going to use this bagel, and if you've seen the movie, you may remember the bagel. This will be my organizing principle for this talk. I'll talk about platforms. I'll talk about some of the media that becomes available for this kind of ubiquitous analytics environment. I'll mention collaboration and some examples there, because the moment we start putting sense-making in the world, we open the doors for multiple people to contribute. And then I'll go through a couple of applications at the end of this thing. So that's my roadmap for today. So let's start with platforms. And if some of these images you see in the background, then you'll note I'm a recent Midjourney convert, so I went overboard with some of these. This picture here is not from Midjourney. This is my lab from 2010 at Purdue. And it showcases some of the kind of display environments that I'm talking about, where on the wall we have a tiled display and then a tabletop horizontal touch display in the center. And the far right corner, you might see someone's hand holding a tablet. So the key thing I was going after in building this lab was just to recognize that in a future computing environment, it's going to consist of multiple devices. They are different computers. It's not just a single beefy computer running them all, because if you do, that's almost like cheating. If you put in multiple graphics cards in one computer and then plug up a bunch of monitors, then a lot of this management of display space and shared resources in computing become trivial. So we wanted, in particular, to think about multiple devices that all collaborate. And this first work, called Polychrome, might be, I think it's the second or third generation of platforms that we built to enable stitching together all of these devices and providing a common canvas for creating these visualizations. And in this particular case, the system called Polychrome was built using web technologies. And just recognizing that the web browser today, it runs on almost all devices, from smartwatches all the way to smart TVs. They have some form of a modern web browser. And of course, web browsers today are very featured. I mean, they have hardware acceleration, they have font rendering, vector rendering, they handle sound, full motion video, and so on. So it's a great starting point for building essentially a distributed operating system, where each node is just a browser, and on top of that, we build software just using JavaScript. The Polychrome system that I'm showing here was an entirely peer-to-peer based system. So there was no server. Instead, it was just broadcasting within the same lab that I just showed you. So it just enables you, in this case, to replicate a DOM, a document object model, for a single website or web page across multiple devices. And you make changes to one, it will be reflected in the others. So this video, I can show you some excerpts. It's nothing special about it, but it's just showcasing a simple D3 visualization where we're just replicating the DOM, so when you make changes to one of them, another computer will see instantaneous updates. So all the events on one gets sent to the other. So again, nothing spectacular, but the thing this enables us to do is we can start building distributed applications with different displays that we can stitch together. So the fourth generation, most current generation of this work, it's called Vistrates. It's a collaboration with some colleagues at Aarhus University in Denmark. And we, in this iteration, stepped away from the peer-to-peer server architecture, peer-to-peer architecture, I should say, into a more traditional client-server architecture, just recognizing that peer-to-peer is super elegant, but it gets into lots of consistency concerns, especially as you're broadcasting and collaborating across long distances. You get a lot of issues in broadcasting. So we ended up using a client-server approach. In this case, again, it's a replicated DOM that runs on a server We use operational transform, same technology that Google came up with for Google Wave and now used in Google Docs to make sure that any changes made to the DOM gets replicated in the correct order to avoid inconsistencies. And along the way, you get a lot of nice features like versioning and so on. So it lets you build shareable dynamic visualizations very simply. And the VisTraits system, as it's called, also provides a component-based framework built entirely in JavaScript, but it enables you to bring together the entire ecosystem of web libraries like Leaflet for maps, D3 or Vega for visualizations, Plotly or HighCharts. A lot of these things can just be brought together very effortlessly and even built with no programming. So let me show you this video. It's going to go a little fast here, and I apologize, I don't have time to go into detail, but what you're seeing is a computational notebook. It's a computational literate programming interface to VisTraits. And what we're doing is we're bringing in a bunch of standard components, one for a map, one for a filter algorithm, one for a bar chart, I think. And then in this view here, we're switching to a canvas view. We're just invoking the visual representations of all these components. And on the right side, you'll see us connecting up so that the data that was loaded gets sent into the input ports of a bar chart and a map. And we're essentially wiring them together without any programming. So in the end, what we get is interactive dashboard. See if this finishes, and you'll see how this works, where you can click on the map, and the map bar chart will update, or you can click on the bar chart, and the map will update. Again, the beauty here is that any of these components on their own could be placed on a smartphone, or on a tablet, or on a tile display, and everything would still be synced up and work live. All right, so the takeaway here from this first part on platforms, we found that in building these multi-device environments, cross-device infrastructures, we needed to have a clear role for each of the devices that's involved, and we want to make sure that transitions between them are seamless.
Can I ask you a quick question?
Yes.
So the complementary angle, I buy a lot, but I'm not sure I saw the demos. I want to like push that a little harder. Can you say a little bit about like what are the kinds of complementary modes that you ended up producing that really worked? Like, was it that the small devices, the phones, were sort of lenses that were focused on specific things, but like there was the person at the control room who was like, what are the modes and what's the assemblage here that really resonates?
Right. So I have a few examples I'll show you soon, but basically, when you have, often it's some kind of asymmetric situation. So in the example I'll show here is a system where you have a large display with potentially multiple people in front of it. It's a touch display. But then if you want to do something on an individual basis, I want to save a query, I want to explore data in some subset, then I would bring that to my personal smartwatch, and I would do those complementary tasks on the smartwatch or the smartphone. And if I'm happy with them, I can publish them back. So I think, is that sort of what you're...
It's sort of like a fork and read.
Yeah, so in that case, and that is not part of this particular presentation. It's work actually Will was part of called Branch, Explore, Merge, one in the audience here, one of my former students, where we essentially used revision control methodology to branch away from the tabletop, do work on your own personal device, and then merge it back into the tabletop if you found it.
Thanks.
Yeah, absolutely. All right, so that was the first piece of the bagels. The second here is on the media. So what kind of unique forms of media are now available to us? The first being just the display infrastructure, the display space itself. So imagine that you have a multi-device environment, and this kind of environment is probably going to change dynamically as you go through your day. So as you walk from the parking garage doing data analysis on your mobile phone, as you do, you'll just have a phone, right? And when you get to your office, all of a sudden you have your desktop computer. And the moment you have this new device, if you have to spend time housekeeping, moving the views around correctly, that's the moment you're going to say, okay, I'm going to stick to one device. And especially as you move, let's say, to a conference room later on in the day, and you have other people, you have a large projected display. Again, if you have to do the housekeeping to manage more than one device, you're probably not going to do it. So in this system called Distribute, our goal was to say, could we automatically handle the layout of the views in a data visualization dashboard, depending on the dynamic availability of devices? And of course, you don't want to do this blindly because some visualizations belong together. For example, if I have a bunch of stock market data and I'm showing it as a line chart, I probably want to keep those together so that they have a common baseline so I can compare across the same time for all stocks. So what we did here is we came up with a bunch of heuristics. You see an example at the lower left part of the slide here of just how are views related? Maybe because they are similar, maybe because they share data, maybe because they have explicit connections, like you have a node link diagram where individual entities are connected. So you want to use that as a heuristic going to the constraint solving that is done automatically as the available devices change. So the Distribute system here, I'll show you a demo, first starting with a single dashboard on a laptop. And the moment you bring in this case, a phone, you'll see one of the devices, the bar chart popped onto the phone. And then in this case, the line chart, the stock market data in this particular case, came onto the tablet. I'll play that again. So the observation, of course, also is that some visualizations just want to be big, like a map. They want as much space as possible. Some visualizations, they like to be wide and thin, or some other configuration. So all of these things can go into the constraint solving in doing this layout. The other media I'll talk about here, there's a bunch of other forms of media, ranging from just multimodal, different representations and interactions. But I'll talk about this one, which is computation, the other side of the coin. If you have multiple devices, each of them has computational power. And assume that you're in some kind of situation, perhaps you're running computations on one device and it's going slowly. You could take advantage of the fact that you have more devices in your pocket to literally increase your computational power. So this VisHive project, it's, again, entirely JavaScript based. It doesn't use an explicit server. One of the nodes in the system will become the server. And without any download, it enables you to share computation for something, let's say a cluster, into these local clouds. So if you're doing some cluster algorithm, let's say, and it's going slowly, you can just bring up a tablet and the load will be shared across them. So it's hard to show a really engaging video of this, but I'll show you here just a brief sample of, in this case, two laptops and a smartphone. Of course, the smartphone is not going to have a lot of computational power to contribute. It's just to show you the idea. And in the end, we could show here at the end of it's a DB scan cluster algorithm. And in the end, it's going to result in the cluster finishing. Yeah. Oops. All right, so the takeaway here is overall it's about automation, because the moment, as I said, you have to start doing a lot of housekeeping, a lot of these ideas will go out the window. So you have to automate and minimize a lot of these challenges. Yes?
Yeah, I'm curious, how do you deal with like lag and internet speed? Especially thinking about, for example, the mobile phone. Was there any sort of friction of it would take any significant amount of time for kind of the visualization to switch over, of people starting to get frustrated with that lag?
Yeah, so we didn't explicitly look at lag, but it is definitely a big factor. This work from a couple of years ago that found if you have more than half a second of latency, people's engagement in the visualization will suffer. So you'll start not paying attention. It will not become a conversation anymore. You're going to basically phase out for a bit while you're waiting. So it is definitely a big concern that we have to keep in mind. But we haven't studied it explicitly in this work. All right, so the third piece here is on collaboration, because as I said, the moment we put computation in the world, and not just on your desktop computer in your office. You can have multiple people collaborating. So in one of these projects I'll talk about from a couple of years ago, we were looking at the idea of proxemics. And proxemics has been suggested as a way to use how people relate to space as a way to guide ubiquitous computing and things like that. So proxemics is this branch of psychology from the 50s, I think, where the way you as a person relate to physical artifacts and other people tells something about what you are thinking and what you're trying to do. So in this particular work, we had this idea that if you have multiple people, again, in front of a shared large display, sometimes these people will want to work independently, and sometimes they'll want to work with each other. And we can determine this implicitly by just observing what they're doing. So it's a tricky slope here, because you certainly don't want to get to trying to understand what the person wants and go all the way to the Clippy spectrum, right? So you want to find some balance here, and this paper became an evaluation of finding that balance. Which actions do you want to do implicitly, and which actions needs to be done explicitly? And we found in general that there's a need for both, and if you're doing an action that will have an explicit, well, a strong impact on the visualization, you will want to do that explicitly. In this video, you'll see two people. They all have a lens, and as they approach each other, the lenses overlay, and then they raise their hand, the lenses actually merge. So that's an explicit action. Now if they then start splitting them, and then they move away, we think of that as they are no longer interested in collaborating directly or closely. So again, we have these lenses, they're controlled by their gaze, they approach, the proxemics tell us that they're collaborating. You know, you converse with someone, you approach them, and then as they move apart, that is interpreted as they want to loosen the coupling. They're no longer working closely together. This final one, I mentioned already a little bit about the complementary types of devices. We call this David and Goliath. It's a study of large displays and smartwatches. The Goliath being the big thing and the smartwatch being the small one. And we found here that there are needs, especially if you have multiple people, for putting some personal information on your personal device. A smartwatch is very personal. It's even hard for another person to see it. You know, you have to really crank your arm to let someone else see it. So it has a very personal connotation. And we found that there were certain things like storage or even using it as a remote control was useful for this smartwatch device. So this is Tom interacting with this large display. And you'll see him do some actions where he's swiping towards his body, which just means whatever I was interacting with, I'm storing it on my device. And then he goes to another part of the screen and he swipes away from his body, which means I'm now placing whatever I stored on my device onto the large display, the dashboard that you're seeing. So here we found, just as in any collaboration, things like consensus and coordination are key aspects. And the benefit of having multiple devices is that many times you can make this kind of coordination and collaboration straightforward. All right, so last piece here on some of the applications that we have explored and continue to explore for ubiquitous analytics. First one is a paper from Kai this year, this past spring, where it's called Relive. We worked with colleagues from University of Konstanz in Germany. And we had this problem where we're trying to understand mixed reality studies when people are moving around in a physical space. You know, this is essentially a research tool that we were using for our own research in other projects. So Relive is all about being able to view 3D tracked data in 3D space. And we found in that situation that there is a need both for doing in situ analysis, where I'm stepping into the 3D space, and I'm seeing these 3D traces of how people moved around, what they were doing during a user study. And there was a need for more of an ex situ analysis. When I'm sitting at my desk, I have a high precision mouse and a high resolution monitor. I can, I see a dashboard, I can do analysis of a more abstract nature. So we needed both of these interfaces. So what we ended up doing was creating an interface, you can see that in the picture here, that enables you to switch between one and the other. So it's a form of a hybrid user interface, where sometimes you do things in VR and sometimes you do them outside in just a desktop. And the key thing we found also, in order to make this work, we had to make sure that there were explicit anchors between the two interfaces, so that when you were in VR, you still had some reminders of what we were doing on the desktop side and vice versa. So this video here will show you the VR view only, but it shows the 3D traces. The yellow lines here, that's how 2 different people were moving their tablets in 3D space. And this is another project that our colleagues at University of Constance were doing. And they had found they needed an analysis tool for this. You'll see that there's a time slider here that we can manipulate to move these tablets in 3D space as time progresses during the study. And then we can also even bring up some of the user interface components that look very familiar from the desktop version of this interface, so that you can have that anchor, that connection between the desktop interface. And on the desktop side, you always had a 3D view of what you had been seeing when you were in VR. The last thing I'll talk about is a paper that was brutally destroyed by the Kai reviewers. I'll talk about it anyway. It's one of the coolest works we've done recently, so hopefully no one here killed it. The paper is called Visualization. It is an augmented reality authoring system for creating visualizations using a HoloLens. Really cool work in my very biased opinion. Probably. We spent so much time on it, so we were kind of devastated. But the system here, as the name kind of suggests, bad pun, we had this observation that when you're authoring visualizations in 3D using augmented reality, you're using a lot of gestures and speech. And it kind of felt like magic, right? You were casting spells. So that's how we leaned into this and used it as a metaphor for the system. So what we're doing is we're providing a system where you create entries using a grammar of graphics to build essentially visualizations, 3D visualizations in midair. So I know it's a very detailed image here, but here's some examples of that grammar. It's a basic JSON declarative specification for graphic representations. So you see at the bottom. And then these are produced using discrete gestures and speech commands. So the gestures are drawn from American Sign Language because we wanted something that was more or less standardized so that you can do these. The video is also, it's 4 different views. I know it's a lot of things going on here, but what you're seeing are 3 different people. This on the lower left is my student Andrea in Maryland, and then these are my colleagues at Bangor University in the UK. In the same same virtual space. They are casting spells. Well, they're authoring visualizations. After a while, you'll see them here. But one after another, they're adding clauses to a declarative specification of a visualization that is going to show up eventually, or it's a scatter plot. And of course, they can all see the same thing, be in the same space, and interact with each other. And and one thing to add here too is that this is all built using web-based, just as the previous ones I said. I feel strongly about web-based technologies for a lot of the infrastructures that we built. That's true for this as well. A lot of the development that's done in data visualization for VR and augmented reality has been done in Unity. And I'm a little troubled by that because Unity is a closed platform and proprietary also. Okay, all right, so let me just close with this takeaway, and I'll talk a little bit about the other work that we're doing in my group. So first of all, the takeaway from these applications, what we found is if we're going to see a future of creating data visualizations in VR and AR, we're going to have to get some kind of standardized systems where you can have, just like in a graphical operating system, you can have multiple applications running and they coexist. So we have to start thinking about interoperability so we can have modular and standardized interfaces. All right, so this is just an overview of the things that I've talked about. Right now in my research group, we're interested in a couple of different themes beyond this thing. It's a big, obviously, component in my research. Last few years has seen people starting to discuss accessibility aspects of data viz, in particular, blind users using data visualization. In fall of 2019, I had a blind student sign up for my data visualization class, which really made me reconsider my view of data visualization. So this is currently a big topic in my group. We're doing a bunch of aspects of using human-centered AI techniques. That's partly why I'm excited to visit Stanford with your center here on using, putting AI techniques into the hands of users. In the picture you see here, we presented on the upper right, you presented this at the VIS conference about 3 weeks ago. It is a virtual eye tracker where we trained using crowdsourced eye tracking data on data visualizations. We trained a CNN so that given a new visualization, you can feed it in and you get a saliency map saying, what would a person looking at this for the first time focus on? Which is useful information for a designer. I'm sitting down, I'm designing a new visualization, not having to run a full-fledged eye tracking study, which costs money and time, of course, to give some fine, quick, rough feedback is very useful. I have a student that's very invested and talented at building things, so we're exploring physical computing aspects for data viz. And then also another theme is just visualization recommendation and data science recommendation in computational notebooks. Okay, that's it for me. I'm happy to take questions. Thank you.
Hi. So regarding the visualization paper, which that seems super interesting, so I'm sorry that one didn't work out like that. But I'm curious what the advantage was to having the gesture recognition alongside the speech recognition, because my thought would be speech recognition is probably a lot easier and a lot less sort of intensive and things like that. So I'm curious what was the advantage in that case of adding the gestures? Did it enable more like commands, or was it sort of just a different way for people to interact with the visualizations?
So it is definitely a lot about being able to precisely point and select when you have created a data visualization. During the authoring, I agree with you that you can be more specific many times using just speech. So that is heavily what is used during although you can do both, but most people prefer speech when they're building a data visualization. But once you are, let's say you make a mistake, you can use your gestures to select which clause that needs to be deleted, much easier than having to use voice commands to navigate. So I think the right answer is a combination of both, and that's the beauty of having both available. One little wrinkle in our particular implementation, because we're using web-based, I think it's Mozilla XR, I forget, WebXR browser, for which one it is. We had issues getting the voice recognition on the HoloLens 2 to work. And so it works fine with their own APIs, but the browser did not. So we have to use the mobile phone for all the voice commands. Okay. So that's just a implementation detail because of the current state of the APIs.
Thank you.
Hey, so it was great to see an overview of all the work. My question is, you know, a lot of the things that you showed about using multiple displays or using multiple devices or even about collaboration, um, those are general things that I might want for all sorts of computing. But you focused a lot on visualization applications, at least in what you showed. But I'm curious how the use of these kinds of general ideas about using multiple displays or you know, devices, how they relate to visualization, right? Like, what did you specifically learn about visualization in these contexts that is separate from what you would, how you would use these contexts for other applications?
Yeah, so you're absolutely right that a lot of these things are generally applicable. So, I mean, I'm a data-viz person, of course, so that is my default. But there are some things that I think that are specific to data. One is a lot of the work we're doing uses situated data, where it has the data itself is in the world. It has a particular location, like in the relive system. So that case, in that case, it makes sense to actually focus on data viz. But I could easily see a lot of these things having, you know, general usage and so on. So it is, I guess, I have some blinders on because I'm a data viz person, but I certainly see that this is relevant to a lot of other areas too.
So a lot of your demos focused on the use of like board scale interaction, right? And of the sort of three tripartite pitch of like tabs, pads, and boards in Weiser's visions, I think the boards are the one part that haven't quite manifested in the same way as maybe envisioned. You know, typically when we see these kinds of things today, they're used for like a single person control and just projecting, like I'm just sharing. Versus if you sort of rewind to the visions, they had like, this ERP collaborative sense making and, NASA movies where everyone's like crowded around the gigantic wall sized display, or like Sherlock, who's just like, doing some mind palace thing that, navigating some complex data space. But like in practice, there's like more manual actuation required. I think what I'm trying to drive at is, where is the threshold where you think this actually flips and we use boards in these sort of interactive, touch sensitive, et cetera ways, rather than just as I'm going to throw it on the wall and you can look at it? Like, what would it take to get us over that threshold in the visualization space where I would use a board in preference to just the laptop in front of me, where I can type and actuate it much faster?
Yeah, I mean, it's a good point. For a couple of years ago, tabletops were big, where everyone were supposed to be gathering around a tabletop, and the benefit being that it's big enough so you can share, multiple people can gather around it. But yeah, they're out of favor, and I think we're just reaffirming this quality computing one device to rule them all. So I don't know. I think we see that too in my lab, that we build a big touch display wall, and it's not being used, and we don't get over that hump where it is actually better. It seems like those settings, I think they're indicative of how things like collaboration in general happens. Most of the time, collaboration is not actually in the same space, same people. Those are a very small percentage. So I don't know. I mean, I guess I sound a little pessimistic, but I don't know if we'll get to that vision of boards and big collaborative things, because it feels like you have most of the benefits on the actual pads themselves.
But it looks cool.
Yeah, it does. Yeah, I was just reflecting on that. I was here in this place, where's the iRoom and so on, all that work, and so it's feels like cool to be here.
Thank you for the great talk. I have a question about, like, where do you see this kind of work going, say, in the next 5 years? a lot of the examples that you showed are focused on like analytics, direct manipulation based on visualization, but like things are changing in this anytime, anywhere, all at once world with like question answering, intelligent analytics, and like presenting insights and interacting with insights. So there is this layer of abstraction from the kind of work you showed today. So I'm curious to hear your thoughts on like in this ubiquitous computing world, like where do you see like the visualization space going?
Yeah, so definitely. So definitely, where is it going? I mean, a lot of the examples that I show here are various relatively simple data visualizations, but we are seeing with various forms of conversational interfaces where you can ask questions, or you have interfaces where the insights, there's some kind of human-centered AI in the background that is trying to highlight or bubble up inferences or insights in there. So I think a future here is one that combines these efforts. And so it's also pretty closely tied to some of the accessibility stuff. A lot of the things we do for accessibility are applicable for human analysts too. When you're moving in a physical world, you have limited attention, you have limited hands to interact with things, then having some automatic algorithms to help you turn out to be essentially a curb cut effect that we can bring in from accessibility as well. So yeah, definitely.
Thank you.
Thank you very much for the talk. I was really interested in a couple of the examples where there were these like spatial or like movement-based interactions. So when you were showing people like swiping from the screen onto their watch, or when there was the collaboration example and people are like walking close to each other to merge it. And I was wondering kind of like how you decide on what movements map to different things, especially like some of them seem very intuitive, like the swiping. I think people would kind of guess that would be, but maybe the raising of their hands to merge wouldn't be. And I was wondering, so like how you decide on those, and if that maps onto kind of the explicit, implicit decision making that you were talking about in the collaboration project.
I mean, it's a very good point. In general, gestures are always low on discoverability. And so this whole argument of talking about natural user interaction is a little fraught, I think. So in the case of the proxemic lens work, where you raise your hands, we were exploring a bunch of different actions and figuring out, in that case, that paper is on a whole exploration saying, where's the boundary between implicit and explicit? But the decisions we made on which gestures to use is relatively arbitrary. So in some cases it makes sense, but some of the actions you're doing are so abstract, so there's no like natural way humans would do that anyway. So yeah, I mean, discoverability in gestures in general is a super tricky area. The one way we try to address it in the visualization work was to use like American Sign Language, which is, you know, some attempt at grounding the actions we were doing with some real phenomenon that people may have knowledge of. But if they don't, that doesn't help them. And even if they do, it's still going to be arbitrary that you have to, you know, sign the first letter for creating a new view in order to create that view. So yeah, I don't have an answer for these things. It is definitely not natural. I think that's a non-moniker, bad moniker.
So I have a question actually. So in the visualization project, you were helping people author these 3D scatter plots. And I'm wondering, like, for abstract, like generic data analysis tasks, I think those are often worse than like multiple 2D views, like you showed in like the large display examples. So I'm wondering, like, do you see, like, why is it good to help people author these if they're perhaps suboptimal, or just your opinion on using those kind of
so
views?
3D visualization, yeah. My dissertation was realizing 3D visualization sucks. So, so you don't want to do, and I'm an ardent adversary to 3D visualization. So it's not a good idea. And what you saw here, we try to do it disciplined, and we try to do it where the 3D stuff is motivated. I mean, if you're doing, the first to realize when I started doing immersive analytics and putting 3D visualizations in augmented reality, is to realize that if you're doing things in augmented reality, your visualizations will exist in 3D, whether you like it or not. So then you just have to realize, how do you do that efficiently so that you don't get into occlusion and navigation and perspective foreshortening and all that kind of problems. So so you want to be disciplined. You want to make sure that the visualizations face you and there's no depth information that's problematic and so on. So sometimes it makes a lot of sense. If the data is 3D, like the traces, then seeing it 3D definitely makes sense. But if you're trying to show, and maybe if it's a 3D surface, that also makes sense. But if it's bar charts, there's really no reason for you to create them in 3D. So I'm aware that our grammar enables you to do this, and it is onto us to guide people in future work to not make those mistakes.
I'm interested though, like, because like people are like, I see a lot of these visualizations that are maps with like the bar charts or spikes and like laid on top of them, and like now that it's getting easier for people to make these, even if like visualization experts think or know it's a bad idea, like that people will just do it. So like, how do you think we should approach that problem?
Yeah, I mean, maybe the authoring tools need to provide guidance to avoid some things like that. And it is easier to do. Sometimes if you do them for effect, they can be useful for storytelling. But if you're trying to compare a bar chart far in the distance to one nearby, you're going to have a bad time. So yeah, it is a problem, and one that I've been battling since my PhD, really.
Thanks for the great talk, and it was great seeing all of these sort of additional interactions that sort of having multiple types of platforms can enable in conjunction with each other. Sort of going back to the conversation about insights, I was wondering if you have any, I guess, insights, sorry for being redundant, or lack of a better word, for like the additional types of insights that could be gathered through having these multiple displays and being able to interact with them in a more embodied sense, that are in addition to just say like having a large dashboard with sort of a lot of synchronized visualizations, or like what sort of these,
So this is a very good point. I mean, every time I review papers on this topic, I ask myself, what's the purpose of doing it in VR or AR? And so you need a good answer to get past me as a reviewer. And I try to do that, turn that on myself too. So there are reasons why you want to do this. One, of course, is that when you have a immersive space, you have more physical space to place stuff in. And you can have embodiments, muscle memory, you can have spatial memory that you can take advantage of. Just knowing, I put my bar chart by my right hip, so I know exactly where to look for it, which is useful information. And then the other reason beyond just placement is the fact that often when you put stuff in immersive, then you get the use of both of your hands, or at least some controllers, so that you can start bimanually grabbing things or moving things around and so on. So I think that is another reason. And then you have some more, maybe more so-and-so reasons, like things like presence being there, and being able to just use physical navigation to zoom in and out, look closer, or compare things, change your viewpoint and so on.
Great, yeah. Thank you.
Thanks. So you're pitching these visualizations that scale from, in theory, like postage stamp size out to like a large wall. And it strikes me that the kind of Cleveland and McGill results that prompted what kinds of visualizations we do where are going to break down at different scales of human perception. Like the kind of rules that we derive from our perception at a scale that's this small are going to be different than the ones that hit when we're really huge. Have you observed where and when those principles bend and break, or do they actually still hold up in all instances?
I think your intuition is correct. And the one thing we have noticed, there might be others, might be that when you might have halo effects where a group of elements influence how certain elements in that group are affected. But of course, if you get close enough, there might be enough white space so that thing diminishes. So in general, I think you're right, and it would be interesting to understand that. I just haven't, and I don't think anyone has either. Most of the graphical perception experiments and similar are done on like standard screens that are relatively small, and yeah, it'd be interesting to figure out.
Okay. Any other questions? Then let's thank our speaker one more time.